All right. The clock is ticking, and it has been a long day, so let's get started. 360-degree monitoring of your microservices. I'm Philipp. I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats. I'm part of our infrastructure team, so I have a bit more of an ops background, but also Java developer. And in infrastructure, we do stuff like running services on AWS, building Docker images, testing Jenkins, though I try to testing with Jenkins, though I try to stay away from that. And I always say this is a Unix pipe. I kind of pipe that out into developer advocacy, so I'm trying to talk about all the good stuff that we do. I don't build real production applications normally, so take this as a disclaimer. This is probably the best monitored Hello World application that you can build. And we will try to get all of the information that we can out of that application. So that is kind of a common complaint about microservices. That once you have that highly distributed thing, every outage and every problem is more like a murder mystery. Since, you're just getting bits and pieces of information, what has been going wrong there and there, and you try to combine that. And unless you're Sherlock Holmes, who probably enjoys that, in IT, when your boss is standing behind you and screams at you, why is this not working, you probably don't enjoy it that much. So we want to try to get away of that detective approach of finding bits and pieces everywhere. Everything is on fire and you're saying, this is fine, until at some point you kind of figure out, well, this is not fine. What is my problem? So let's see what your problem is and what we can do against that. So Sam Newman, he did a talk earlier today. He had this very nice quote. The first thing you need is you need aggregated logging, and the second thing you do if you have something highly distributed is you need correlation IDs. So there are basically three things I want to look into today. The first thing is centralized logging. I guess most of you have heard about Elk Stack, what we try to call now Elastic Stack. The second thing are metrics. It's just like having high-level overview of what is going on in your system. And the third thing are traces. So you have something unique on every request, and then you can trace that request throughout your entire system. So these are the three things I want to really look into. Yes. Logging, monitoring, and tracing all the things. That's kind of the topic. So how does everybody log and monitor? Who is using SSH and tail? You can admit it, it's okay. Anybody? Nobody's using SSH and tail. I don't believe it. So if you still do that, I can try to help. Who is already using the Elk or Elastic Stack for centralized logging? Okay, there's not that many, so we still have some work to do. Who is using centralized logging in general? Okay, more work for us. Good, good. So I have some small application. You can totally clone it and run that yourself. I have called it microservice monitoring. And we'll just run through that, and I will show you all the different bits and pieces that you can run. So it is a very simple application. I'm using Spring Boot, though I'm not going into all the details of Spring Boot. It's very simplistic. It doesn't do any advanced discovery or load balancing or anything. It's really just about the monitoring. For this microservice talk, I'm sticking to this definition of microservices. As long as you give it short names, it's a microservice. So yeah. And of course, I run everything in the cloud, so actually you will need to do some work. I hope the internet is stable enough for me, but it will all be on AWS, and you will generate the requests for me. Let's see how that goes. So I'm using, since I'm kind of cheap, I'm using the Amazon Lightsail instances, like the cheap instances which are pretty much like DigitalOcean or whatever. I'm using Terraform to provision all the cloud stuff like DNS, get the instances, and put all of that together, and then Ansible to deploy my application, configure all the services. All of that is in the repository, so if you want to see that, then you can take a look. If we have time at the end, We can dive into that as well, but that is kind of just the ecosystem that we have. And we have our own cloud service, so the one that AWS provides is kind of a competing service, but we provide Elasticsearch and Kibana as a service, and obviously I'm using ours to show off how to centralize everything. You can totally run that locally as well. It's just Docker-based, but yeah. For extra fun and a bit more thrill, I'll try to run it off the cloud. So we have the general stack. I'm just using Beats, Elasticsearch, and Kibana. So Beats are like the lightweight agents or forwarders we have. Logstash can do parsing and enrichment and has more complex logic, though we don't really need it for today, so I've left it out. Elasticsearch is what stores your data, and Kibana is there to visualize everything. So let's start with some monitoring. I have some, and this will be awfully small. No, I don't need you. I'll just start something. I have some jar. I have called it bad jar. That is just allocating memory to run into an out-of-memory exception. At non-Java conferences, I always say this is kind of the purpose of Java, though I need to be a bit more careful here. So if you have not seen it, this is Kibana. That is where all your data can be combined and you can visualize it. So what I'm doing is I have imported, I don't need you now. I have imported a lot of data or a lot of dashboards, since I didn't want to build them myself. So you don't have to build all of these. I have just imported them. And I switch to the process view, so you can see from all my servers, I have various processes running. And for example, let's make that small enough so it fits on our screen. So I have 3 nodes running here, and I will run my bad jar on one of them. And you will have to figure out kind of where it's running. So we have Java. Let's give it a bit more memory, 512M, jar. Bad jar. So this is just allocating memory in the background, and here actually what we should do is we want to have this auto-refreshing, so this should refresh every 5 seconds. And in 2 or 3 reloads later, you should see that we have some Java process that is, by the way, that green one here. Some Java process should start misbehaving if we've done everything correctly. Right now, it's still looking kind of tame. Okay, it's still running and allocating memory. Oh yeah, and suddenly you see something here is spiking up. And now you can see my Java process is getting worse and worse and worse. And we'll just let it crash. So only if you have kind of like a centralized metric aggregation to see that, you will find that, because that thing will crash within half a minute or so, and then it's just gone. And every now and then you might have some spike, and you might not really be aware of like what is going on in your system and what has been happening. So we have MetricBeat running here in the background. That is something that is just collecting metrics like Top would do, and stores them centrally in Elasticsearch, and then in Kibana we can visualize that. So that is running here, and I'm just waiting. Yeah. Now you see spike here. My process should have crashed by now. Let's see. And yeah, this worked as planned. Like out of memory exception was the plan, what we wanted to get here. Next up, we can actually do something a bit more productive. So I have my application running already, and you can start following along here. So I'm just going to Xera, which is my Twitter handle and everything. By the way, if you're wondering like where's that name coming from, that is a rot 13 of my last name. So if you rotate the letters of my last name by 13, then you get to that. And I have the domain WTF. And you should get to that page. So everybody, since a lot of you have probably their phones out, you can go to that site and generate some requests for me. Or if you have your laptop out, I can use some requests here as well. If anybody feels like it, you can also try some SSH connections to my SSH server. We'll get into that in a moment. Let's see how creative you are. So you can go to that URL. You can go to /good. That will just say greeting. You can go to /bad. That will give you the general WhiteLevel error page. You can go to foobar or any URL that doesn't exist, and you will get the 404. It will give you the 404. And you can just generate some requests here for me. So, yep, I see you're at work because the CPU is already spiking here for my Java process on that instance. So that is the front-end instance where all the requests are going. And thanks for the requests. Let's see what is going on. So the first thing I have here running in the background, I have Nginx running on port 80, and that is proxying the requests to my Spring Boot application. So we have something called a FileBit module. By default, Nginx logs everything to var log Nginx and then access log or error log. Let's take a quick look at access log. And you can see all the requests are going here. And FileBit is generally collecting log files. And we have now added something called FileBit Modules. And that module thing just knows, for example, for Nginx, on your operating system, where does that log file live? What is the pattern? So for example, it will know in that position here we have the date and the timestamp. Here we have the HTTP verb. Here we have the response code. We see what accessed that page actually. All of that is in that log file, and it has a standard format. So that FileBit module is just parsing that and is storing that data nicely parsed, including dashboards in Kibana as well. So we don't have to do anything. We just have, I've just enabled that Nginx module. I can actually show you how that looks like. FileBit YAML. So you can see we are collecting some stuff here. We say that is the instance name, and I'm monitoring my system and my Nginx instance. We also collect Java logs. We'll get to those in a moment. And then we're sending that to my Elasticsearch instance. Yeah, don't do anything bad to my cluster, since these are the credentials. But I will reset that right after the demo, so don't worry. So let's see how that has been going. So we go to the Nginx dashboard, and we can see, oh, there are a lot of requests from Poland. Unsurprisingly, so you did a great job. So those are a lot of requests. And so you can see how many good and bad requests we had. We can see which URLs were accessed the most. And we can also see the breakdown of the browsers. So for example, we can see, I don't know, how many mobile Chromes we had, mobile Safari. We see the versions like the distribution of iOS and Mac. But I'm actually only interested in my front-end instance now. So here, you can just, that is from everything that is sending data, but you can totally filter that down. So we have something called beat name, and I only want the front-end instance here. And you can see, okay, these were all the requests to my one front-end instance. And if we start zooming in here, let's see how good our geolocation lookup is. So the geolocation lookup is basically you have an IP address, and that gets translated to the geo IP. And it looks like nearly everybody is on the conference Wi-Fi, and that is mapped to one specific point, which is not Krakow. But yeah. That's kind of the thing with geo IPs. They are not that accurate. Like normally you get kind of the country or at least the continent right. But every now and then it just goes a bit like off on the city. So yeah, depending on where I talk, sometimes it's super accurate and you can really tell like this is the building we're in. Here, let's just say we're in Poland, which is hopefully close enough. And just to show you what that looks like, in the raw files, so it's not always just the magic here. Come on, FileBit, load. I hope my network connection is not dying. Okay. So we have somewhere I'm only interested in the source, and the source is that access log. So you can always filter down on that. I hope that is large enough for you to see. So you can see these are all the files we're collecting here on a frequent basis. And here I can just say I'm just interested in that access log. So I click on that little plus sign that will add that filter up here. And then out of my nearly 20,000 requests, we'll see how many came from Nginx. Come on. You can filter that down. OK. And one of the requests, and this is actually, oh yeah, somebody accessed home with a 200. And you get the geolocation. So that was one of the requests internally, so that looks like it's from the US. But you get all of that enrichment of the information. And what we also do automatically in the background, on AWS, we can enrich that AWS meta information. So you know what instance type you used, that was EC2, which region you were using, what instance ID you had. All of that is enriched automatically for you. So you didn't really specify that anywhere. The only thing that I added was I said I want to use this processor, and this will automatically fetch through the AWS API, fetch all of that information from the instance, and enrich your information. So that is pretty convenient. OK, now that was from the files, but we also have something else that's called PacketBeat. PacketBeat is a lot like Wireshark. But Wireshark is really the thing, if you have a lot of distributed services, it gets very painful because you need to collect all of the logs then or all the network traces on all the servers, combine them, just to see what is going on. And PacketBeat is taking a bit of a different approach. So PacketBeat is using the same base library, libpcap, and then collects the network headers and just stores them in Elasticsearch as well. So here, I can go to PacketBeat dashboards. And this is just monitoring all the network traffic from all my instances. And you see, I don't have it is large enough, hopefully. I don't have any database running here on my instances. I just have web transactions. You can see over time the web transactions. You can see how many requests did you have and what the latency distribution was. So you can see all of that down here, the green thing, that was very fast. Everything else is getting slower and slower. You see percentiles of response times. You see how many errors did we have. Like here, stuff was getting worse. Error count over time and the latency histogram. So probably you had some very slow requests. Yeah, some request took 10 seconds, but most of my requests were here up somewhere like 0 seconds. And then we have the whole thing protocol specific. So what PacketBeat basically does is it monitors your network interface, and it knows what is the request and what is the response, and it extracts a lot of information just from the headers. So it knows the protocol is HTTP, the response code is a 200, a 500, or whatever. The whole thing took 100 milliseconds, and the URL you accessed was foobar. So again, let's say I'm only interested in the requests to beat name frontend. You can always filter that down for all the graphics up in that search bar, and it will be applied. So we had, to the frontend instance, we had 7,700 HTTP requests. Most were too good. Some of you already called the slower services. We had 980 500 requests. And you can see what requests we had. So most of the requests came to good, / called bad. Yeah, somebody got more creative with hehehe. Though you're a very serious crowd. Like I've seen much more interesting stuff in here. Like sometimes people can try to give feedback like good, bad, whatever. And I also had it that somebody did try to do script injections. So they put in a script and said like alert hello, which doesn't work. We escaped that. Don't worry. So, but you can try it. Like they tried to hit something that would trigger a scripting exception in here. But yeah, somebody, I guess that was just one person because that is too random that multiple people guessed it, did a lot of refreshes here. Yeah. So you can collect all of that information and you see what is going on your network. So just so I don't lose track, we have seen MetricBeat, we have seen PacketBeat, we have seen FileBit Modules. Oh yeah, the one thing that we probably are interested in now, we had all of these bad requests. So we had 980 bad requests, and we probably want to know what has been going on here. So what my instance does is I'm logging everything, but I don't log to standard files because it's always a pain to parse it back. I only log to JSON. Because then I can, since Elasticsearch stores JSON as well, I can just directly collect that JSON information and then store that. So what I get is, I don't need sudo less var log. I put that into apps, I think, and then we have front end, like the name of my application, JSON, and that is just the entire log of my application. So you just, while it's a bit hard to read, that is one log entry, but since it's JSON already, you don't need to do any complicated parsing anymore. So we have the timestamp explicitly, we have the severity, we have the service, we have trace ID, which we will get later, and you can see here we have the entire stack trace of that whole thing. So yeah, that view is not that nice. We can totally see that in the Discover view as well. So I need FileBeat as well, though this time I'm not interested in that one. Come on, load my file here. Oh, and we had so many that those are now limited to that one. But the one that I really want, if I would see it, input type, that is what I want. But all of those are logs. That is kind of unfortunate. But we can just say front end. No, front end is not good. Front end dot JSON, I think. That should be better. Yes. So with frontend.json, if we open one of those up, since we knew that is the location, and I just put in the file name that was kind of explicit here, with type, you can also filter down on the type. That is probably what you want. On the type, we can just say, I only want the Java applications, and in there only what is in the file frontend.json. And here then you can see you have a lot of information explicit, like you know, like from which host, you know the source, like from what file it came. You know that it was an info, and you see that was the exact call stack that we had in here. And that is kind of the nicest way to extract all of that information. So I'm just logging out to JSON, since this is normally the easiest way to kind of do that. What else do we do? Oh yeah. So one other thing is, if your service should be highly available, you probably want to kind of ping it. Since we have our own cloud offering, we were using Pingdom and other services for a long time, but later on we decided, well, we have the beats, so it should be easy to do that on ourselves, on our own. So we have written something called Heartbeat, though I have stopped that so it doesn't generate requests all the time. Oh, something I have totally forgotten. Did anybody try to log in with SSH? Let's find out. Yes, quite a few actually did. And none of you were successful, luckily. And these are actually all the usernames. Oh, somebody doesn't like Kibana. We can talk about it later. Come to me and we discuss it. It's kind of, yeah, you can always see what is going on. And for whatever reason, most of the requests are from Russia. That's also kind of typical, I guess. Stuff that just happens. Nobody really knows why. And down here, you see all the requests, like which IP address, and either somebody from Russia got really wild, or somebody's using a VPN, or the IP address got wrongly allocated. But somebody has been really trying to get into that instance. And I'm pretty sure the Russian was not who wrote Kibana sucks. This was somebody here. But this is kind of nice. If you have any server out there, since in the auth logs, that information is also widely accessible, you can simply collect that automatically and see what is going on. Or if there had been like a successful login here, what would have been also interesting, for example, no, that's not called root. You can you can also see like which sudo commands were run recently. Okay, I have accessed that file twice, that is correct, but luckily there were no other sudo commands recently. So that is also kind of a nice sanity check, like which sudo commands are people running and what are they actually up to. Or you can see with audit D, were there any bad events that happened? And no, luckily, no successful SSH events that should not have happened. Or I think we're collecting syslog as well. And here you can see everything that is going on in syslog. And you can see, what did we have? Yeah, mostly the DHCP client, cron, systemd. So all the events that your system is generating, all of that is being collected. And that again, that is the system FileBit module. So it didn't really do anything. I just said like, FileBit, collect the system events, and then you can centralize it and see all the stuff that is going on in your instance. So that is nice. What was the next thing I wanted to do? Oh yeah, heartbeat. I stopped in the middle of heartbeat. So I wanted to SSH, by the way, if you want to try again, Ubuntu is my username. Monitor. No, I'm using a certificate, don't bother with passwords. So we have heartbeat running here, but I think it is stopped. Yes, stopped heartbeat. So let's start heartbeat. So what heartbeat is doing is it's basically pinging a service, just to show you how easy that is. I'm showing you the configuration file. So basically we're pinging /good every 10 seconds with a timeout of 3 seconds, and we expect the 200 to come back. Otherwise, that thing is marked as a failure. We're adding the cloud metadata again, and then we're outputting it into our Elasticsearch instance, like the usual thing. We, of course, have a dashboard for that. And you can see, oh, that's up, that's nice. I've just started it, so that's why we don't have any data here. But here we have started it, it's up, it's running. That looks kind of good. But we can now, I can either kill the Java application or I can stop Nginx. Let's go for the Java application. Service, front and stop. And I think, yeah, that's okay. Localhost 8080, it should not be available anymore, yes. Yeah, and here we get a 502, a bad gateway, so that should also be picked up by our pinging service. I've used the Spring Boot system integration, so you can actually run it as a service just for convenience. And we can enable auto-refresh here. Oh yeah, and that was quick. So while I've stopped it, you can already see like, okay, our service is marked as down. That's not really ideal. Let's start it up again, and then it should return to normal again. Oops. No. And then, yeah, the warning is not what can be ignored. That should be good. Let's wait for one or two more refreshes in Kibana, and then our service should be up again. I think my front-end application takes something like 20 seconds or so to start up, plus the pinger pings every 10 seconds, so it's probably taking half a minute or so until it is available again. And yeah, you can see it's getting better, 1 or 2 refreshes, and that one here should turn green again as well. Or I'm getting too impatient and just reload everything. Come on. Okay, I'm not going to wait for that one. But that will turn, like, after 1 or 2 more requests, it should then turn green again, and that should all be good. Okay, other stuff that we can do. Since we are using Spring Boot, we have metrics and health. I can do that from anywhere, it doesn't really matter. Curl localhost 80 health. And it tells you up, and we have metrics. And we're not authorized. And of course, I forgot what my username was. I think admin and secret. If anybody wants to follow along, yes, you can do the same. So this information is kind of nice, but it's very ephemeral. Like you ping and the data is gone. Wouldn't it be nice if we could collect all of that information as well? And we can totally. Right now, this is not integrated in any of our beats, but somebody from the community was nice enough to write something called HTTP beat. And HTTP beat can access any endpoint, collect the result of that, and then store that into Elasticsearch. So that is what we want to do here. So I'm just starting that sudo service heartbeat and no, sorry, HTTP beat should be start. And then let's see if HTTP beat is doing anything. Hopefully. No. Do we have any data in here? And if not, why not? Come on, HTTP beat. You can do that. Started. Okay, that looks good. No? That is interesting. Let's check what is going wrong. That's always nice in demos. So there should be an, yes, we have HTTP beat here and it has 24 events. So that should be correct. But I screwed it up. Probably you will do the same thing at some point. So how to get the data in here is you have this index pattern management. We will just can that one and create a new one. So what we want to do is we add a new one. We say it's called HTTP beat. And since we create a new one every day, I just add that wildcard here. You can see, yes, there is a timestamp value. I want to use that timestamp value. And I want to auto-expand that one. OK, so we have created that one. Let's see. OK, it's working. The demo gods are friendly today. And what we're doing here is we're just pinging with HTTP beat. And it is collecting all of the right metrics down here. Let's see. Yes, that looks very familiar. So for example, we can see, so this is collecting, for example, the current heap size, the committed heap size, all of that what is being exposed by health. And that can already be very useful. So any application that exposes some REST endpoint, you can continuously collect that and then display that. We can shut that down again, since we don't need too many requests here. The other thing is, since we're using Java, we probably have JMX somewhere. Who is exposing data with JMX? Anybody? Jolokia? Anybody? No? Nobody? That is confusing. OK. So with Java, you can expose metrics of your application with JMX, and Jolokia kind of makes it sane by exposing this at HTTP. And metric beat can also collect that information. So on that host here, I'll quickly show you how we are collecting all of that information. So these were the ones where I collected the information of the process. That is pretty straightforward. And that here is my Jolokia metric. So in metric beat, we have this integration into Jolokia, and you can see that is kind of the right setting, including authentication, to collect JMX metrics from a Spring Boot application, but that should be very easy to customize for any other application. So I am collecting some garbage collection information, the uptime, some memory information, etc. So all of that is just from the JMX endpoint. I'm collecting that. And then, let's see if we can find that. So we're switching over to MetricBeat where this information is going. And in MetricBeat, there will be a lot of metrics because my 3 servers are every 10 seconds for every single process indexing a document and also collecting the JMX information. So to filter down just to the, right now we have 42,000 events here. So just to get to the JMX ones, we want metric set module. And you see here, Jolokia, I'm just filtering down to that 0.6% of Jolokia events. And then we can open up one of these. And you can see, okay, this is exactly what my JMX endpoint is exposing. So you can either use REST, or if you have a JMX endpoint, you can totally use JMX as well to collect all of that information. And now we could just start graphing that out. And it's very handy that we have a new visualization tool here, which is under Visualize. So in the latest version, we added something called Visual Builder that is a bit more complex than what we used to have, but is also much more powerful. Now you can do, for metrics, you can get very detailed statistics of things. So for example, let's make this one red. Let's call it heap. And here I want to have a sum. Here a sum. Then we say there should be somewhere a field called heap. That should be heap usage. And you can see, so this is out of all my Jolokia events, this is the heap usage over all my instances. And by the way, that number on the right-hand side, that is not that helpful. Let's make that a bit nicer. Let's say this is actually in bytes. So once we switch that over to bytes, you see, okay, we have proper megabyte values. But this is aggregated over all my instances, so that is not that helpful yet. But you also have this group by event down here, and you can then just say, I want to have that based on a term. And the term we want to have is we have a beat name, beat.name, and I want to group that over who is using the most memory. And here you can see for all of our 3 instances how much heap usage they are having, and if one of them is exploding. So for example, you can see frontend was using a much more heap back here than the others, and now I have kind of limited down to, yeah, they're all the same, and you can see like the typical saber-tooth garbage collection. So that looks all pretty sane, and they're all somewhere between 40 and 60 megs of heap usage. So that is very nice. One other nice thing that you can add here is you can do something, you can annotate. For example, every time you deploy, you could annotate that here. I will just deploy my bad jar because that is super slim. I don't want to deploy my 30 megabyte Spring Boot application. So that should be... So I'm using Ansible. What Ansible is doing in the background, it's compiling, I'm using Gradle, or it's packaging, I'm using Gradle. It's deploying the jar file, and after that, it is writing an event into Elasticsearch so that I know I have deployed at that point in time. So if we go over to the raw view of my documents, we can say, here we have the events, and I'm interested in, that is a range query where I say, I want all of the events since or in the last 24 hours, basically. Or actually, we could say, we want all the events in the last 5 minutes. And there should be exactly one if that has worked. Let's hope so. And yes. So I'm just, with a REST command, or with a put, I'm just saying at this point in time, I have deployed the application bad to that instance. and we want to annotate that in our graph here. So if we deploy something, we would see like, oh, something has gone wrong. Like you have deployed something and suddenly your application is screwed up. What has gone wrong here? So you have this tab annotations. You can say, I want to get data from, my index is called events. We have a timestamp field. I don't want to limit that. Let's use, I don't know, which one is nice? Let's use a bold. The required fields, I want to have the two fields I had that are kind of meaningful were application and host. So let's add them, application, host. And then you can say app, my application name is, oops. This application here is that variable application here. And then I say, let's make a few spaces, host is host. And you can see here you have your annotation, and you can see you have deployed. And if you hover over it, it will show you, okay, the app we deployed was bad, and the host to which you deployed was front end. And since this didn't do anything here, but if suddenly you would see kind of a big spike, or you would suddenly see, oh, you have more 400s or 500s than you used to have, then you would know, okay, this was a bad deploy. And we could then store that, and together with other visualizations, we could put that into a dashboard, and then you can, in your dashboard, also see, like, here you have deployed, and here you have screwed something up. Okay, the final thing we wanted to, or should look into, is distributed tracing. So I have my front-end server and my back-end server, and they're calling each other. So if you went to that page here, you saw we could, you could generate slow requests. And if you run that one here, you can see it takes like nearly a second or something like that. I have just added a random weight here. And I now want to see like what was actually slow. Was it the front end? Was it the back end? Which method of my system was actually slow? So you can access that if you go to monitor, that is the monitoring instance, and that is running Zipkin. So there is Sleuth, that is the application or the thing in Spring Boot that once the request hits your service, it gets a unique ID, and that ID is kept throughout your service. It looks something like this. So in your logs, you will have something like this. So you see here we have logged something. The application was front end. That is the trace ID, and that is the span then. Span is basically, they call it unit of work. It's basically like a method call. So everything that happens gets those two, and then you know, okay, this was the application we hit, the trace ID, the span ID, and then we're sending that information to Zipkin, and Zipkin can actually show us which were the slowest requests and where did they hit. And the nice thing is Zipkin has 3 backends, and one of them is Elasticsearch. So if we go to that tab here and we run indices, you can see we have an index somewhere. There is Zipkin, which I cannot see right now. It should be Zipkin. Oh yeah, here. And you can see we have 315,000 Zipkin events actually collected. So that can be stored here as well. And the Zipkin UI is this one here, and we can say, I want to see all the requests that hit my front end and everything that has happened today until, let's say, 8 o'clock, so we're sure we have everything. And then I can say find traces, and I'll make that a bit bigger so you can actually read it. And then you can see, okay, these were the traces that we hit. Those were slow, pretty quick ones. Let's generate 1 or 2 slow ones. And we can also get the slow 500. And we run that again, and hopefully we'll find that one. And you can see, okay, something here took nearly 400 milliseconds. The red thing, this was an error. And then you can see, okay, we called that method. That took most of the time, so the slow thing was here. And then it called bad, and bad was super quick. Like quick, that one took 10 milliseconds, but that one spent nearly the entire time of that trace. And then you know, okay, this is actually the method that is slow, and here you can then start diving down, like, why is this one slow? And probably you want to also take a look like, why has that one taken so long? Like, let's take a look. What's the slowest request? Okay, yeah, and then we have other faster requests. And here you could just also see, like, even if it took some time, that Jolokia endpoint hit just took 15 microseconds, but the entire thing took 15 milliseconds. If that is still too slow for you, you can then just start diving into that and see what has been going on. And if you're currently debugging and you want to know, like, why is that taking so long, there is also a Chrome plugin. I managed to get it up here. That adds a tab Zipkin here. We have our instance here. If I hit my slow 500, you will have the ID here. You can click on that, and you will be taken directly to that slow request. So if you develop that and want to debug why is that one request slow, that is kind of the easiest way how to see what is going on here. Okay, we've seen annotations, other stuff. I didn't really go into. You can do alerts. So for example, I have defined an example alert that says here, if your service is down for more than 2 pings in a 2-minute interval, then I want to be alerted. And you want to have that. You can also do that. We have something that is unfortunately commercial that is called machine learning, which is basically anomaly detection of time series data. That just knows what is kind of normal in your system and will alert you if something is not normal. So here, for example, you can see everything was kind of in some rhythm, and here suddenly you had twice the traffic that you normally had. So here you can see twice as high as normal, and that could alert you to that. Stuff we will get into the future. Right now, I miss that especially for my demos. I need to create my cloud instances all by hand for our cloud service, since we don't have a proper API, but we will soon have Terraform integration so you can automate that part as well. What we don't have right now are rollups. So right now you probably want metrics in 1-minute intervals or like 10-second intervals. But later on, maybe you want to have them only every, I don't know, 5 minutes, and later on every 30 minutes only. We'll hopefully later this year, let's see if we still manage that, have rollups where we kind of aggregate those metrics over time to also save disk space and make the calculations faster over time. And we just announced today, we bought another company, so we bought something that is a bit going in that Zipkin direction, so it will do tracing for you and it will be a bit more clever. So for example, it knows these things took some time, but that can even link, this is for JavaScript, I think, can link to the source code that is generating why something is slow or why something has been misbehaving. It will still take some time to integrate it into our stack, but that is kind of on the roadmap to have better tracing functionalities. Yeah, final thing, while doing this talk, I kind of figured out that this talk should have been called different. Like I will rename it for the future the Holy Trinity of monitoring with logs, metrics, and traces. And I want a quick show of hands, like, should I either theme it like this or like this? Like, since both is Trinity. Who's for the first one? Few. Who is for Bud Spencer and Terence Hill? That's pretty even, okay. I'm still not sure which one to take, but I need to rename that talk. To conclude, our stack is a bit like Lego. You can build pretty much anything you want, but it takes some effort to put it together. So in the example repository, we've seen like system metrics and network traffic. We've seen FileBit modules and system modules to collect that information. We've looked at application logs, which are ideally JSON. We have pinged for uptime. We looked at application metrics from REST and JMX. And we did request tracing to see, or to follow one request throughout your system and see how that has been going. We're nearly out of time. There are some stickers if you want stickers. You can ask a question, and I always want to take a picture with you so I can show to my colleagues that I've been working today. Because otherwise, they always think I'm just slacking off. Smile, everybody. Very nice. Any questions in the meantime? Very nice. Any questions? Or everybody up for beer? Yes. Yes, unfortunately, that is one of our commercial extensions. But if you're using the cloud service, it's included for free. So if you're just using the open source version, you don't have all of the icons you have been seeing here. So you will have Discover, Visualize, Dashboard, Timeline, Graph, but you probably don't have monitoring, and you don't have this user stuff down here. Those are commercial extensions. Like, this is how my salary is being paid. And I have a lot of colleagues by now, so we're more than 500. So there are lots of salaries to pay. How you can configure it? So there are like, you can, by default, there is no authentication in general. You can have that. Then you can have two other things. You can do document-based security and field-level security. So field levels is say everybody can see all the fields, but some specific fields are just for specific users. Or documents is like if a specific condition is met or not met, it should be like it will be shown or not shown. Like what we will also bring out in the next major version, that's 6, that will come out later this year, is that you have more fine-grained permissions of who can see which dashboards. Because right now everybody sees all the dashboards, even with the commercial extensions, but we will fix that later on this year. And if you're using cloud, you can already do that, or otherwise we provide commercial plugins for that. You cannot really limit it down too well, because like authentication you can do with a reverse proxy quite easily, but you cannot do any advanced filtering of the documents within that then. So that is an issue. But on the cloud, security is available. Any other questions? Yes? Oh yeah, totally. So the alerting thing is, like in cloud you get it, it's called Watcher, since it watches. I have configured one for Heartbeat here, and if you open that up, you see, okay, a lot of them were okay, but there should be some failures. Yeah, here. When I stopped my service, I had these events which fired, and they basically told me that here I had 2 bad pings, but if I go back, like the other ones should have more bad pings. So this should have something like 6 bad pings, I guess, or 4, okay. So with alerting, you can basically, it's a bit like a cron job. You say, check for some condition every X minutes, hours, whatever. And I have configured that one, and it checks every minute. It checks, did you have downtime in the last 2 minutes? And right now, I'm just writing these events, but they can also reach out. Like that it can send emails, it can do PagerDuty, Slack, it can automatically create Jira tickets if you want that, and it can call webhooks, so you can pretty much do anything. Unfortunately, the watchers are also something that is paying my salary. But on cloud, again, you get those included. So it's just part of the cluster that is running. They might look a bit scary in the beginning if you want to create them. So I say, I'll make that a bit bigger because it's probably unreadable. So every minute I want to check. My query is, in the last 2 minutes, did I have something where the uptime was false? And the condition is, if you hit more than 2 of those in the last 2 minutes, I want to be alerted. So that is kind of the simplest alert you can create. You can totally write alerts, like if your heap is bigger than X or X%, or if, I don't know, you suddenly have more 400s or 500s, you can define alerts on everything. In the next minor release version, there will also be a more graphical way to define those alerts then. Right now, this is a bit bare bone, and yes, you can have the conditions, and you can run them here and simulate them, and you see the results, but it is still a bit bare bone. So if you want to add a new one, you can write something here, then you can just simulate it, and you can see, okay, this is firing, and you can see why this is happening. But yeah, we're trying to improve the UI on that. The backend is there and has been working for quite some time. Sure. Any other questions? Or everybody wants beer? Beer? Yeah. Well, thanks a lot. Don't forget stickers.